This is the second in a series of 8 chemistry labs on the fundamentals of biodiesel. In this lab, we will learn about chemical reactions. Written procedures, including background information for all 8 labs, is provided on the Biodiesel Education website. A chemical reaction is when different chemicals come in contact with each other, and a change takes place involving the disappearance of a substance and the appearance of a new substance. For instance, when methane reacts with oxygen, there is combustion which results in carbon dioxide and water. To combine chemicals in just the right amount to produce the desired reaction and have nothing left over, we need to know the chemical formula of a reaction. Knowing the formula allows you to calculate the molecular weight, so you can adjust the right amount of chemicals together and not have anything left over. In this laboratory exercise, we are going to create this chemical reaction. The compounds calcium chloride and sodium carbonate will dissolve in water, and when mixed will form a third compound, calcium carbonate, that is not soluble in water and will precipitate out. From the chemical formula, we can see that one calcium chloride molecule combines with one sodium carbonate molecule to form one calcium carbonate molecule. The table salt formed will stay in the solution and is of no concern to us in this lab. The first step is to take 2 250 milliliter flasks and fill each with about 200 milliliters of distilled water. Label one calcium chloride, CaCl2, and the other sodium carbonate, Na2CO3, and put them aside. Using the periodic table, calculate the molecular weights of calcium chloride and sodium carbonate. From the chemical formula, we know calcium chloride has 1 calcium atom and 2 chlorine atoms. Looking up the individual atomic weights on the periodic table, we find the atomic weight for calcium is 40.078, and chloride is 35.453. Adding the molecular weight of 1 calcium atom and 2 chloride atoms, we get 110.984 for the molecular weight of calcium chloride. We also find that the molecular weight of sodium carbonate is 105.988. Since we do not need this much reactant to demonstrate this chemical reaction, divide the molecular weight of calcium chloride and the molecular weight of sodium carbonate by 10. 1/10 the molecular weight calcium chloride is 11.198, and 1/10 the molecular weight of sodium carbonate is 10.599. Carefully weigh out an amount in grams numerically equal to 1/10 the molecular weight of each compound to the nearest 0.01 gram. Pour the calcium chloride into the flask with the calcium chloride label, and the sodium carbonate into the flask with the sodium carbonate label. Insert a rubber stopper and shake each compound until they have been dissolved. Now pour these two mixtures into the larger flask. Insert the stopper and shake until thoroughly mixed. Observe the precipitate that is formed and watch it fall to the bottom. The precipitate, which is a new substance, is calcium carbonate, which is used as an antacid to relieve the symptoms of indigestion and heartburn. There is a simple check to determine if we have used just the right amount of reactants to produce the calcium carbonate. When the upper liquid is clear and free of any precipitate, pour about 50 milliliters each into 2 clean beakers. Add a few grams of calcium chloride to one beaker and a few grams of sodium carbonate to the other. Stir until they have dissolved. If we have mixed the correct amount needed, there will be no calcium chloride or sodium carbonate left, and no precipitate appears in either sample. In this lab, we mixed calcium chloride with sodium carbonate. When these chemicals came into contact with each other, a chemical reaction occurred and calcium carbonate was produced. Thank you for watching the Chemical Reactions Lab on the fundamentals of biodiesel. Please go to the Biodiesel Education website for a complete written transcript of this lab exercise.